Welcome to the stream. We're going to look at why my video VGA timing core didn't work last time. It didn't work because I didn't simulate it. I was just trying to get it to work because I tried to do this within the hour and not much time. So today we're going to actually simulate the VGA timing core with the version that is for the icebreaker. Let's see how it goes. So first, I'm going to create new projects for simulating this. I'm just going to bring in both the Verilog and VHDL file and then instantiate them and see how it goes. We're going to say sim time. Right. Doesn't really matter. But we can do it. So you can do mixed library. You can do Verilog. You can do VHDL. It's fine. So first, let's go add our two files. So one file is going to be here, sources, block diagram, design. Oh no, it's going to be in the IP repo. Stream, IP repo, stream function, DVI stream, HDL, VGA timing. Okay, and then we're going to add the other one, which is going to be located in DVI for sources, block diagram. No. VGA core. Really? Where did they get added? Did I not add them when I did the whole thing? So they're probably in downloads. We'll just do it this way. 12-bit VGA timing. Okay, we have VGA timing VHD and VGA timing V. That's bad. We're gonna have to change one of those. We'll change mine to DVI timing. Okay, so let's finish. We're gonna have to rename mine because it's not going to be happy about that. So yeah, because there's two, it's gonna hate it. So let's go here and there's got to be a way we can rename this thing. Not? Oh, it's because I didn't add it? Well, here's what we'll do. We'll create a new file and we'll just copy and paste it. Create file and we'll call it DVI timing .vhd, make it VHDL, finish. Okay, yes. And we're going to open these two. Take this, add it here, and just DVI. That should be sufficient. So our library should consist of VGA timing and DVI timing. Okay. So now we want to create a top level that's going to instantiate both of these two, send to the same setting, and have a reset in, and have HSync, VSync, and active out for both of them. We don't really care about the colors, we just care about VSync, HSync, and whatnot. Oh, we could try that. It might be another important thing. Another note is maybe when we blink, we actually have to blank the thing. So for blanking, when active, we may actually have to turn the color off. So we may have to do that when pixel read is low. When pixel read is low, we may have to set it up so that the color that's saved, pixel data 1, right here, is black and not the color. We may have to do that. So, well, first let's create a new VHDL file. My brother said he did not like me doing VHDL. It was painful to watch. Sorry, but I prefer VHDL over Verilog. Well, I don't know. System Verilog is much better for test benches, but we're not doing a real test bench. I'm just going to stimulate it a little bit. So I don't know. I can see it go either way. We're going to need a clock in. Yep. And a reset in. Yeah, good. So clock in. Yep. Let's do active 0 out standard logic. H-sync, V-sync. And that's all we really need to know about. Okay, now let's do some component instantiations. Okay, so let's do DVI timing first, I guess. I have to figure out how to figure out the components going for that. Component. Okay. Then we need to declare it. DVI for I. We just right. Map. Okay. Guess it wants all those things. Let's go make it. Let's see how much I can actually get this to work. Timing control. So signal. Let's do timing control. Timing control, the standard logic vector, 31 down to 0. Others. Right. And timing control 0 will equal reset. So these are supposed to be constants, right? And let's look at PGA timing for those constants. We need to do standard logic vector and do unsigned, and then do what, 44, 32. That really how verbose we need to go. That looks how verbose we need to go. Okay. Put this there. Okay, 44, 148, 1920, 88, 200, 5, 36, 20, 80, 4, 1, 2, 5. Pixel data in. Doesn't really matter at this point, but interesting. We'll keep it there. In case we need to add a blank to it. go ahead and open that guy. So now we're probably not going to do like a full auto check test bench. We're probably just going to keep our eyes on it, just because I think we don't need a crazy test bench to test this out. Okay. So that looks like we got that one going. Now we want to do a template for this. So we have reset, a clock, new frame, new line, active, active. This is much smaller. So to do Verilog in, do a Verilog in a VHDL, you just gotta kind of just do a component declaration, and it's pretty happy about it. And we're just gonna do like that. This needs to be out. 1, 2, 3, 4. Got one? No, I think we're good actually. Okay, and we need to end the components. So we want to do VGA underscore I. It's going to be VGA timing port map. Let's just go like this. There we go. Reset. Black dot not now. Black dot. You can just say open. Oh, and this is going to be A1. It's going to be H0 here. H1, B1. So we should have plenty to go ahead and test this guy out using, we'll do some tickle script. Let me get a new instance of Notepad++ going. Tickle script. This instance script going. That way I can bring it to the stream screen. DVI time.tickle. I guess we call it do file if we really wanted to. Okay, cool. We have our tickle scripts. Close that out. Okay, so let's run simulation. Oh, first sources. Okay, cool. We're gonna run a simulation, but first let's go to simulation settings. I do not like how simulation automatically runs as soon as you do that. Let's not do that. And yeah, that's okay. Run behavioral. So our signals may be delayed from each other, I assume. We're both trying to start the same state. We both started the H-sync and V-sync reset state. And we'll check that out. So first thing we want to do is we want to create a clock. We're going to force a clock. Leading edge value 0, trailing edge value starting after nothing, duty cycle period of 1 nanosecond, so we can keep track of it. Hit OK, take this tickle command, add it here for future reference. And so what we're going to do is we're going to force a value, force it right now to 1. And then we're going to run 10 nanoseconds and force it to 0. So run 10 nanoseconds and force it to 0. And let's see what happens when we run 100 nanoseconds. We may have to run this for a long time. So, okay, let's go ahead and look at this, right? So it looks like our clock isn't changing. Let me try running 1,000 nanoseconds. Okay. So we have something in here that's causing it to not be happy. Even though the reset was high. So what's happening here? Oh, that's why we're here. We want state. Counter. Okay, so what values we're looking at here? We want to see H-sync. And H-sync is coming from this one. So let's trace it back to the originals. So H-active, or H-sync right here, we're going to add to window. H-sync next. And then we're going to add these 3 to the window. Did I not connect it to the out port? Guys, I think I did the stupidest thing ever and didn't actually connect it to the output. So maybe that's why my core didn't work. A very simple mistake. Active equals, after being double registered, active register 2. So we're going to have vsync register 2. I don't think I never connected them to the output. Okay, so we get to click so do hit key right here, and we're going to copy this. Copy. I'm going to paste this, and let's go look at the waveform. Okay, so that's fine. So we start with vsync here, and this starts with vsync low. Can we bring up that source? I'm curious to. I thought they started vsync low. So they go frame pointer. Oh, they started off at the state front porch. So let's go ahead and do that same thing for ours. So they line up. Here we have it sync, but we want it at FP. So yeah, let's re-elaborate and just see if it matches. And then I want to check if they don't blank the data at that level, they blank the data at the top level, or at a different level. So we're going to look at that file real quick. So go ahead and run that. We'll look at the waveform. Must be the front porch. That shouldn't be high there. What's the active though? That was V0. Vsync. Let's go down here. Go back down to the vsync behavior, and we want to see. So, what state are we in? Vsync. Restart. Curious. So let's see. Why is it counting that fast? So let's look at the condition. Where are in this counter equals active? Rollover is only on the transaction. This condition, the counter must equal that value. So let's drop down the counter and see what we got there. Really weird that it's going. I wonder if it's because we have the same time. Okay, let's go here. Let's rename these guys, right? So we have that. Okay. Let me get this better lined up. There we go. And so we're going from floating point here This is a bug with Avado? Let's drop down the other counter while we're at it, you know? I'm just curious. Why is the state... I'm gonna add this guy's state as well. Oh, he's H6, he's going on top. Oh, is it just because I have the rollover high? I wonder if it's just because I have the rollover. The first cycle, it's going from floating point, from front porch to back. Oh, I know what we can do. Go here, let's drop down the next state logic. Stick that above. I'm curious. It just constantly thinks it's going to be... What's the next state set to in that situation? Think. Is it because the first cycle we don't have next state set to anything? Why is next state sync for that one? Trying to figure this out. So counter's not moving. Next state logic is just sync. Did that affect? Is it doing some type of reset? Even then, it should be automatically assigned. So also want to go in here and French porch. Oh, that should also be French porch. That's a waveform. Yep. Okay, let's see. Let's run it for 1 millisecond. So let's roll around again. Let's so second. What you get for doing this resolution. So that's running in the background. I mean, so we have logic goes to back porch, goes to V active, front porch. Okay. That's appropriate timing. So what's with the reset logic? What value is not getting reset? You can reset to 0. I should have. Well, that shouldn't matter. That should. Next counter. Oh, we forgot the most important thing. Next state equals current state. Have the state logic persist. We didn't provide a default for the state. Therefore, the state is volatile, creating bad logic. We didn't cover that case. So let's go ahead and cancel. Go ahead and refresh. And when you haven't done a state machine for a while, you forget the nuance of it. Yeah. So here's our tickle scripts. Copy that. And let's see what we got here. So they're only a few cycles off. That looks good. Let's take all these things to the bottom. So we have this. So let's go A1, H1, V1. Let's run 10 milliseconds. Let's see what we got. So the only thing I can think of is automatically blanking the color. So well, I want to see if it automatically blanks the color when it's not active. Also, I want to make sure the actives are, relatively the same time here. Okay, let's just zoom out slowly. I don't really care about the new lines. That is dramatically different than this one. Whoa. That is definitely overcounting somehow. So let's look at this. It should, that is definitely counting correctly. That is not counting correctly. Did I make the same mistake? Oh yeah, this needs to be front porch. Okay, that would solve probably our problem. So let's go to tickle script and let's run 5 milliseconds. Okay, back to the watch window. Figure out what's going wrong. So active looks pretty good. H's look pretty good. V looks pretty good. So let's make sure the H's are live well within each other. One's not breaking apart. So 92. You see that? They're slightly longer. So let's go find out why. So do they end in the exact same one? It's what, like exactly 2 clock cycles later. So it should be exactly 2 clock cycles later. It's not. Let's make sure we put the right values in. Oh, I see what's the issue. When you do a counter, since are these considered unsigned? These are unsigned. I just do a 1. So we're counting poorly. -1. I just say -1, we'd be happy. We want to, it already counts the first value of that tick, right? We don't, when we count to 4, we don't go 0, 1, 2, 3, 4, we go 1, 2, 3, 4. And that's the same idea here, is that we need to because how do they do it here? And yeah, they start the count at 1. And we could do that. But I like starting the count at 0. Okay. Okay. Solving all our timing issues. I'm glad we have the other system to verify it's working, so we have a golden version per se. So, okay, let's take a close look at the H's. So those are pretty darn consistent. Okay, so let's take the V's. It looks like RV is way earlier than is, which means RV active is not the correct thing. See, what did we set RV active as? V active we set as 1080. Radix, let's make this decimal. Assign decimal. I flipped over there. We also started way earlier. Our sync is significantly shorter. So our sync is 7, their sync is 11. So their vsync 5. Four. That really makes the biggest difference. They start at 0. Now it starts at 1. Okay, so let's relaunch, see what happens there. Oh, oh, we should be good. Since we're doing the early part. Okay. So both began 1, 2, 3, 4. 1, bring the counter up here. 0, 1, 2, 3, 4. On sync. We made 5. Oh. So these things are only allowed to roll over and the transaction can only happen there if that is high as well. So it makes everything slightly shorter. There's a better way we could implement this. Let's do it right now for simplicity's sake. Oh, I think I forgot. There. Okay, let's rerun it. Ugh. Ugh. As soon as it gets working, we're going to check the color, and I think I'm going to call that for the stream. So okay, cool. Let's zoom in. Otherwise, there goes like that. Count B. We don't have Radix. Oh, their rollover just starts immediately. So let's just see though if we match. Let's run for 5 milliseconds again. Good. Just something in their code causes their H rollover to happen earlier. So they start at front porch, and their count almost immediately goes to 2. Yeah, because they start with rollover, so they immediately go to a 2. I mean, if we wanted to match their behavior, what we would do is we would have rollover start as a 1, and we should match their behavior perfectly. Okay. Besides a few glitches of registering our signal, so they're a few cycles later. Now ours should be consistent. So let's see what we got going. So do this. The V syncs look like they're lined up. We zoom in. And just ours having a cycle later than theirs. The effect are active. Looks like one of the like our active is still on the front porch. The active. Oh, that's that guy right there. And let's go look at when they assign their H rollover. They assign it right then and there. Oh, they just react to in the same cycle. see. So our rollover down here. So they have an H1 and a V1. It's also based upon their state. So our two states, sync and then sync. While their two states seem to synchronize at the same time. Let's see if I can understand. So these are non-blocking. They're saying the next counter is going to be +1. And all we care about is the rollover. Here's the next cycle, so it should match. For ours is 8. Oh, they're just having that giant if statement. That's how they got rid of it. Curious. Trying to think this one out. So what we're having here is the active is not lining up the same way as there is. And what we could do, let's just bring in H rollover and see what that does. So this is our H rollover. And I don't see their H rollover. Makes this a little bit hard to simulate. Yeah, let's just restart and see where that H rollover is coming from. So that's RH rollover. So it's happening for that. So H roller goes high. We go into sync. Oh, it's registered by 2. Okay. So our counters change at the exact same time. Let's get their H counter. Okay, this is the last thing, and then we'll probably have to end the stream. It's getting radix, and so okay, cool. This is interesting. So looking at this, this changes here and outputs here. So this outputs after the second cycle. Ours outputs after when we're double registering. So they output theirs earlier. So it's not that they're H, they're delaying their H. So let's go figure out how they're delaying their H. They're delaying theirs by at least 1 cycle. The state is decided here, and then 1 cycle. Our state is decided here. Register it 1, 2, 3. See how we do it. Sense to me. So when it's 1, we're in sync. No, when it's 0, we're in sync. You store this to hsync next. So there should be 1 cycle after 0. So there should be 1, 2, 3, and we immediately output it. So 1, 2, 3. So theirs is being registered a second time. And that is when they get to sync, They register it there, and register it there. So they have 2 registers, we have 3. What about the VG? So they're only changing on the thing. So go back here, they are changing here, and they only have 1 delay, right? 1 delay for VSync. Why is their VSync so much faster? Oh. That's why they do it when it's transition from the front porch. So what they're doing is when they leave the front porch, they put their sync high. Okay, oh, that's not what we want. Nope. Okay, so now we see them. So now we are lining up like that. Does this close? So first cycle after them. Cycle after them. Let's go check out this one. Okay. So just to make this work more like theirs, we're just going to take this right here. Do that. Out. Redundant. Exact same behavior as theirs. Let's see. Yeah, sorry, I'm just thinking here of what we're doing. We haven't lost many frames. I'm probably just being quiet if you aren't hearing anything. Hard to come up with things to talk about the entire time. Just trying to make sure things line up the way we expect. Oh, I see what I did wrong. I broke it. And so these things need to carry over. So they're now like these default. I wonder if we could just change the clock. Desync. Active. And those are on the, we gotta put those in here. Yeah, let's see what this does. So now it's lasting one longer. Oh, and count does not equal vsync. Let's look up something real quick. As vsync when you should use it. That's a different type of vsync. Doesn't really help much. But I don't know. So we've done a little bit of different behavior now. We just go back and do the other behavior? Because, well, we gotta make sure it works. Because this doesn't go into sync until after this flops over into the sync state. That's a good question. Okay, well, I'll think about it. Maybe I'll find some VGA instructions. Okay, well, that's it for now. Thanks for watching, guys.